Hi everyone, another video with another example related to Coulomb's law. In this example we have an object with a negative charge is positioned between two fixed positively charged objects with charges Q1. Here is Q1 on the left, it's 0.24 Coulomb, and Q2 on the right, it's 0.55 Coulomb. Now as shown in the diagram, once the negatively charged positioned, it will remain constant or suspended or at rest, which have a really key things to answer this question. The distance d1 between the negatively charged object and the object closer to it, it's 2.5 centimeter. I called it d1, but we know it is 2.5 centimeter. Now we are trying to find how far is Q2 from the negative charge Q3. Okay, now when I mentioned that the negatively charged object remains at rest, this indicates that the total forces acting or the net electrical force acting on Q3 will be 0, which means the force generated by charge 1 on 3 will equal the force generated by the on 3 because of 2. They have to be equal in magnitude and opposite in direction. And that will be the start of answering this question. So I will say if the force on 3 because of 1 equal the force on 3 because of 2. From here I have Q3 Q1 over D1 squared equal, that's squared, sorry, let's fix it. Now that's K Q3 and Q2 over D2 squared. Okay, now if we look carefully to what we have, I can simply eliminate the constants and Q3 from each side, which leave us with Q1 over 2.5 10 to the power minus 2 squared, that's the value of distance 1, equal Q2, we can place the values later, and I will call it D2 still as it is, squared. With a simple math and replacing value if you want to, you can say it's 0.24 over 2.5 10 to the power minus 2 squared equal, this one here is 0.55 over d squared. Let's finish the example here. We just follow the math and some calculation with the cross multiplication. You will have 124 d2 square. Sorry, I don't know why the mouse keeps doing that. It's really annoying. Equal. You multiply the 2.5 10 to the power minus 2 squared with 0.55, that will give you 0.34 10 to the power minus 3. Now d2 square will be, you just divide both sides on 0.24, it will give you 1.43 10 to the power minus 3, but we are looking for d2, not d2 squared. So d2 under square root, that will give us 0.038 meter, or if you want to keep it in centimeters, that will be 3.8 centimeters. meter. That will be the distance of Q2 from Q3 to keep it suspended, or to make sure that the total net force acting on Q3 because of the two charges 1 and 2 will equal 0. Okay, which makes sense because we know from Coulomb's law and the relationship between the force and the distance between the two charges. The bigger the distance, the smaller the force. So even I represent that in my arrows. I draw the force between 3 and 2 as a smaller arrow compared to the arrow between charge 1 and 3. Between 1 and 3, the arrow or the force or that vector is longer because it's a bigger force, it's a smaller distance, where the force between Q2 and 3, the force vector is smaller because the bigger the distance, the smaller the force acting. So we have to keep that in consideration. All right. I hope you find this example useful, and hopefully we see you with another one. Thank you.